In today's tutorial, week 1, we have two examples to look at. One requires calculations in force and acceleration, and the second one is basically about force, balance, and pressure. So let's have a look at the first question. A crane is required to lift a mass of 250 kilograms from a resting point on the ground to the top of a building 100 meters above the ground level. When the mass reaches that point, 100 meters above the ground level, we hope it's moving at 10 meters per second. We need to compute the force, the work, and then the motor, the power of the motor that we want to use. So let's have a look. If we're going to compute the force, we need to know the acceleration first. So we need to know a good formula for acceleration using the information that we have here. A useful formula that lets us do that is written there in orange. We basically already have the final speed. We know the initial speed is 0 because we're assuming that the mass is sitting on the ground, not moving. We also know the distance this mass travels while it is accelerating constantly, so we want to compute A. So we can do that. On the right hand side, we can see our computed acceleration is about 0.5 meters per second squared. This allows us to compute the force. The force is just ma, but we have to take care here because we're not just working against the force caused by acceleration, we have gravitational force too. So we have to add our 0.5 onto gravity, which is 9.81, and we get that force there. This allows us to compute the work, which is integral of force over distance. Since the force isn't changing over this distance, we can just multiply it by FD, or multiply it by distance, and that gives us our work performed. And note the unit, so it's the joules. The next step is to compute the power required. Power is just a work divided by time if your work's not changing over time. So we need to know what the time is. We can use that formula shown there to compute time, and we can see that it would take about 20 seconds to lift that mass from ground up to 100 meters above ground level. Using this time, we're able to compute the power, which is W divided by T. That gives us about 12 kilowatts, which is reasonable for a crane. Now, of course, when you answer questions like this on an exam paper, you're not going to complete your working in a circle around the question like I've done on these slides. You're going to lay out your answers in a nice linear format like I've shown here. And you can see how each part of the question is following on from a previously completed part of that section, and each of the key answers that you've computed is easily seen by the examiner. By doing this, I'm able to see where you've made mistakes and give you part marks accordingly. And this brings us to the second example. Here we have two piston cylinder arrangements connected by a tube. One of the pistons is larger than the other one, with piston A being 0.5 meters squared and piston B being 0.25 meters squared. We have two questions to answer. One, which piston is heavier and how many times heavier? And B, if we apply a force of 1000 newtons to the smaller piston, what force will we produce at the larger one? There are two important concepts that we have to understand here to answer this question. One of them is a force balance concept, and the other one is regarding pressure. When we see two cylinders connected by a tube like this, we have to know that the pressure in both cylinders is the same. If the pressure in A was larger than B, then fluid would move from A into B until the pressure was the same. We know the system is in equilibrium, which means nothing is moving, so the pressures must be the same. On piston A, we can see there are two forces acting. One is gravity, mg, and on the other side is pressure of the fluid acting against in the direction opposite to gravity, which is Pa. Now you'll notice that I haven't included atmospheric force on this. There's an atmospheric pressure on the other side of A, which means that the pressure that we're looking at there when I write Pa is the gauge pressure and not the absolute pressure. So, since we know these forces are equal, we can equate them, and that gives us an equation for pressure in terms of the mass of A and its area. Since the pressure is the same at B, we can write a similar formula for the pressure at B, which is mBg divided by AB. We can equate these because the pressure is the same, which gives us a relationship between the mass of those pistons and the areas of those pistons, and we can see that that lets us work out that Ma is 2 times mB. Now we can look at part B. We want to know what happens when we apply a force of 1000 newtons to the smaller piston. So when we apply that force, we're going to be increasing the pressure underneath the cylinder. So we can compute the increase in that pressure. That's 4000 pascals. Now we know that pressure is going to be applied at A as well, so we need to work out the resulting force at A. The area of A is 0.5 meters squared, so when we multiply that by the pressure, we get a force of 2000 newtons. So we can see that we've effectively increased the force. And this is what we call, this is an example of a force amplifying system. Again, when you complete these solutions, you're not going to write the solutions in the same way I've shown you on the slides. You're going to lay them out in a very clear and linear fashion. If you need more help, you can come see me anytime in room 714, or you can email me at the email shown there. Good luck, and I'll see you next class.